Okay, so we will discuss this question from our advanced problem series of kinematics. So the question is, a car moves rectilinearly from station A to the next station B, rest to rest. Okay, so there are two stations, A and station B, from rest to rest. So initial velocity is 0 and final velocity is also 0, with an acceleration varying according to the law F is equals to A minus bx. So the pretty first thing is this F is not force, this is acceleration, and A and B are constants, and x is the distance from the station A. Okay, this is x. Okay, the distance between the two stations and the maximum velocity r. Okay, so we have to find this distance, let it be d. So we have to find d as well as velocity maximum. Okay, so let's start. See, we will write this acceleration as v dv by dx. Okay, why v dv by dx and not dv by dt? Because this acceleration is varying according to x. Okay, so that's why we will write v dv by dx. Perfect. So let's integrate this. V dv is equals to a minus bx into dx. Okay, we will integrate this. When the velocity is 0, the distance is 0. At velocity v, the distance will be x, let's say. So the integration will be v square by 2 is equals to ax minus bx square by 2. Perfect. So v square can be written as 2ax minus bx square, or v can be written as under root of 2ax minus bx square. Perfect. So let this be the first equation. Now what we have to find, basically we have to find the distance. Okay, so for distance we can say that the velocity is becoming 0. Okay, so from this equation we can see that if I put v is equals to 0, which is if my velocity is 0, I'll get two answers from this equation, because it is a quadratic in x, and even from our diagram this makes sense, since the initial velocity is also 0. So the uh, one value of x will be 0 and the another value will be the our answer, that is nothing but d. Okay, so let's put v is equals to 0. We will get, if v is equals to 0, we will get uh, and I'm squaring it, so I'll get 2ax minus bx square is equals to 0. So bx square minus 2ax is equals to 0. So I'll take x common, so bx minus 2a is equals to 0. So one answer will be x is equals to 0 and another will be 2a by b. Perfect. So velocity is 0 at x is equals to 0 and velocity is 0 at 2a by b, which is our nothing but d. So 2a by b is in option C and D. Okay, so let's find out maximum velocity. So for Vmax, okay, we can say that the derivative of velocity uh, will be 0, since we have to find the maxima. Okay, so acceleration will be 0, or the another logic would be see, if I have this station A to station B, the initial velocity is 0, the final velocity is 0. So if I started moving with an acceleration f, then there will be a certain point uh, after which the acceleration will be nothing but your retardation, or you can say negative acceleration, to make our velocity 0 again at the station B. So uh, at some of the point the acceleration would maybe 0, right? So that's why we will say acceleration is 0. So if acceleration is 0, we have this equation, acceleration is equal to a minus bx. So acceleration is 0, which is a minus bx. So from here we can say that x is equals to a by b. So at a distance of x is equals to a by b, our acceleration is 0. Now let's see this via diagram. So see, this is station A, this is station B. Okay, the whole distance is nothing but 2a by b. So the half of this would be what? This distance would be what? A by b, right? And at this position, at this midpoint, we are having acceleration 0 and velocity, maximum velocity, okay, something, okay. So can you see that this will nothing but this is the main position of an SHM. This basically particle or this car follows an SHM, right? So you can even solve, or you can even get this clue via this equation f is equals to a minus bx, which is a linear equation given of acceleration, right? So yeah, you can even solve it via SHM or the basic approach of kinematics. So let's see. So what will be the Vmax? Now we have x is equals to a by b, so we will just put this x and we will get that Vmax value, that is under root of 2a. The x is a by b minus b into a square by b square. Perfect. So this b will get cancelled out. This is 2a square by b minus a square by b, so this will be under root of a square by b. So this Vmax will be a by root b. Perfect. So our option D is right.